We can now use everything we've learned in order to evaluate angles in all four quadrants of the unit circle. Let's start in quadrant 1 with 45 degrees, and we'll focus on sine on this slide. So 45 degrees is formed here in quadrant 1. The sine of 45 degrees is equal to the opposite over the hypotenuse, or square root of 2 over 2 over 1, which is simply square root of 2 over 2. Notice that the sine of 45 degrees is positive because the opposite side, square root of 2 over 2, is positive, over the hypotenuse 1 is positive. Now let's look at 135 degrees, this angle here in standard position. But since it's not a quadrant 1 angle, we need to determine its reference angle, which is here, between the terminal side and the x-axis. Note that the reference angle is 45 degrees because it's equal to 180 degrees minus 135 degrees, which equals 45 degrees. Now we can evaluate the sine of 135. So the sine of 45 degrees, its reference angle, is square root of 2 over 2, the opposite side, over its hypotenuse 1, which simplifies to square root of 2 over 2. Again, notice that the sign is positive because positive square root of 2 over 2 over that hypotenuse, which is also positive, is a positive number. Let's now evaluate 225 degrees, which is formed by the standard angle here, and we can find its reference angle. Since the reference angle is the difference between the terminal side and the x-axis, we know that the reference angle is also 45 degrees because 225 degrees minus 180 degrees equals 45 degrees. Now we can evaluate the sine of 225 degrees. So the sine of 225 equals the opposite side, negative square root of 2 over 2, over the hypotenuse 1, which simplifies to negative square root of 2 over 2. Notice that the square root of 2 over 2 is negative on both the opposite side and the adjacent side. So the triangle, the numbers of the lengths of the sides of the triangle have been adjusted to reflect its position in the unit circle, or the quadrant that the triangle is located in. Finally, we can evaluate 315 degrees, which is formed by this angle here, which is really this angle going all the way around the circle here, and then determine its reference angle, which is the difference between the terminal side of the angle and the x-axis, which is 315 degrees, subtracted from 360 degrees, again, 45 degrees. So now we can determine the sine of 315 degrees using 45 degrees as our reference angle. So the opposite of 45 degrees is negative square root of 2 over 2. Notice it's negative because we're in the fourth quadrant, over the hypotenuse 1. So negative square root of 2 over 2 over 1 equals negative square root of 2 over 2. Now pause the video and do a similar analysis, but this time you're going to evaluate the cosine of each angle rather than the sine. The cosine of 45 degrees, evaluating this angle here, is simply the adjacent side, square root of 2 over 2, over the hypotenuse 1. So it simplifies to square root of 2 over 2. The cosine of 135 degrees so the cosine of 135 degrees, evaluating this angle, using this as our reference angle. So our reference angle is 45 degrees once more. Forgot to fill that in at the top here. So the cosine of 135 equals the adjacent side, negative square root of 2 over 2, over the hypotenuse 1 equals negative square root of 2 over 2. Next, we're going to evaluate 225 degrees and its reference angle, 45 degrees, because 225 minus 180 is 45 degrees. And the cosine of 45 degrees in quadrant 3 is equal to the adjacent side, negative square root of 2 over 2 over the hypotenuse 1 equals negative square root of 2 over 2. And finally, the cosine of 315 degrees equals, we're going to evaluate this angle here, which is really this angle here all the way around the circle, and its reference angle, 360 degrees minus 315 degrees, is a positive 45 degrees, and the cosine of 45 degrees in the fourth quadrant equals the adjacent side, positive square root of 2 over 2 over the hypotenuse 1, simplifies to square root of 2 over 2. Notice that the reference angle was 45 degrees in all four quadrants. Now we're going to do a similar exercise, but with a reference angle of 30 degrees in all four quadrants. And in this one, we're going to use the cosine. So if we look at the cosine of 30 degrees formed here, we know that the cosine equals the adjacent over the hypotenuse. So positive square root of 3 over 2, because we're in quadrant 1, over the hypotenuse 1, which simplifies to just square root of 3 over 2. Next, we're going to look at 150 degrees, and its reference angle will be 30 degrees because 180 degrees minus 150 is 30 degrees. Now we can evaluate cosine of 150 degrees using 30 degrees as a reference angle. So the adjacent side of 30 degrees in quadrant 2 is a negative square root of 3 over 2 over a hypotenuse of 1, so it simplifies to negative square root of 3 over 2. Again, notice that the signs reflect the location of the triangle and the quadrant that it's in. So because we're in quadrant 2, the x value, which is the negative square root of 3 over 2, was negative, and the y value, which is 1/2, was positive. Now we'll look at the cosine of 210 degrees formed by this angle here, and our reference angle will be between the terminal side and the x-axis. So 210 degrees minus 180 degrees equals our 30-degree reference angle. Now we can evaluate cosine of 210 degrees using a 30-degree reference angle. So cosine is equal to adjacent over hypotenuse. The adjacent side is the negative square root of 3 over 2, and the hypotenuse 1, which simplifies to negative square root of 3 over 2. Again, notice the signs of both values of the lengths of the sides of this triangle. In quadrant 3, the x value is negative and the y value is negative, so the square root of 3 over 2 is negative and the 1/2 is negative. And our last angle, 330 degrees, this angle here, which really is evaluating this angle here, and we're going to find our reference angle, which is going to be 360 degrees minus 330 degrees equals our 30-degree reference angle. So the cosine of 330 degrees, using our 30-degree reference angle, the adjacent side of 30 degrees is a positive square root of 3 over 2 in the fourth quadrant, and the hypotenuse is 1, which simplifies to square root of 3 over 2. Now go ahead and do a similar exercise for 30-degree reference angles, but this time we'll be using the sine function. You should have determined that the reference angle in each quadrant is 30 degrees, because the reference angle in quadrant 1, it's just 30 degrees because it's a quadrant 1 angle. In quadrant 2, it's 180 minus 150 degrees, which is 30. In quadrant 3, it's 210 minus 180, which is 30. And in quadrant 4, it's 360 minus 30, which is 30 degrees. So now that we've established the reference angle, we can very quickly and easily determine the sine of the angle in each quadrant. So the sine of 30 degrees is opposite over the hypotenuse. So the opposite side is 1/2 over the hypotenuse 1 equals 1/2. In quadrant 2, the sine of 150, using the reference angle 30 degrees, the sine of 30 is a positive 1/2 over the hypotenuse 1 equals 1/2. In quadrant 3, we have 210 degrees. Using our reference angle of 30 degrees, the opposite side of 30 degrees is negative 1/2 over the hypotenuse of 1 equals a negative 1/2. And in quadrant 4, 330 degrees, using 30 degrees as our reference angle, the opposite side is negative 1/2 over hypotenuse of 1 equals negative 1/2. Finally, we're going to evaluate reference angles that have an angle of 60 degrees. We know the reference angle is 60 degrees for each one because in quadrant 1 we have a 60-degree angle. In quadrant 2 we have 180 minus the 120, which is 60. In quadrant 3 our reference angle is 240 minus 180, which is 60. And in quadrant 4 our reference angle is 360 minus 300. So our reference angle is 60 degrees in each quadrant. And now we're going to evaluate the tangent of those 60-degree reference angles. So the tangent of 60 equals the opposite side, square root of 3, over the adjacent side, positive 1/2. So we have square root of 3 over 2 over 1/2. When we divide by a fraction, we have to multiply by its inverse, so square root of 3 over 2 times the inverse 2 over 1 equals 2 times the square root of 3 over 2. The 2's cancel out, and we're left with the square root of 3. Next, we'll evaluate the tangent of 120 that has a 60-degree reference angle in quadrant 2. The opposite side is a positive square root of 3 over 2. The adjacent side is negative 1/2. So square root of 3 over negative 1/2. We're going to multiply by the inverse of the denominator, negative 2 over 1, and we're going to end up with negative 2 times the square root of 3 over 2. The 2's cancel out, and we're left with the negative square root of 3. Next, the tangent of 240 has a 60-degree reference angle in quadrant 3. So the opposite side is negative square root of 3 over 2. The adjacent side is negative 1/2. And now we're going to evaluate that. Square root of 3 over 2 times the inverse of the denominator, 2 over 1. By the way, the negative in the numerator and the negative in the denominator canceled out, so it's going to be a positive number. So square root of 3 times 2 is 2 times the square root of 3. 2 times 1 is 2. The 2's cancel out, and we get a positive square root of 3. In the last quadrant, quadrant 4, we're evaluating tangent of 300 degrees that has a reference angle of 60 degrees. And the opposite side is a negative square root of 3 over 2. The adjacent side is a positive 1/2. So negative square root of 3 over 2 times the inverse of the denominator, 2 over 1, equals a negative 2 times the square root of 3 over 2. The 2's cancel, and we're left with a negative square root of 3. Now go ahead and try this last one on your own and pause the video. We can see that our reference angle is again 60 degrees because we have a 60-degree angle in quadrant 1. We have a 120-degree angle in quadrant 2 with a 60-degree reference angle because 180 minus 120 is 60. We have a 60-degree reference angle in quadrant 3 because we're evaluating 240 degrees, and 240 minus 180 degrees equals 60. And finally, in quadrant 4, we're evaluating 300 degrees, so our reference angle is going to be 360 degrees minus 300 equals 60 degrees. Now we can easily determine the cotangent for each angle. So the cotangent of 60 degrees is equal to the adjacent side, positive 1/2, over the opposite side, positive square root of 3 over 2. So to solve that, 1/2 times the inverse of the denominator. The 2's cancel. We're left with 1 over the square root of 3. Rationalize the denominator by multiplying both by square root of 3. And we get square root of 3 over 3. Next, we're going to evaluate 120 degrees that has a 60-degree reference angle. So we're looking at right here. So the adjacent side of 60 degrees in the second quadrant is negative 1/2 over the opposite side, positive square root of 3 over 2. So we're going to multiply this out, negative 1/2 times the inverse of the denominator. The 2's cancel. We get negative 1 over the square root of 3. Rationalize the denominator, and we get negative square root of 3 over 3. Next, we've got 240 degrees. Erase that and evaluate 240 degrees here. with our reference angle here. So the cotangent of 240 using a 60-degree reference angle, the adjacent side is negative 1/2. The opposite side is negative square root of 3 over 2. So the negatives are going to cancel out, so we'll end up with a positive number. So we have 1/2 times the inverse of the denominator, 2 over the square root of 3. 2's cancel. We're left with 1 over the square root of 3. We're going to rationalize the denominator by multiplying by the square root of 3 over the square root of 3, and we get square root of 3 over 3. And last but not least, we're going to evaluate 300 degrees. Oops, that one canceled out there. Okay, 300 degrees. So our reference angle again, 60 degrees. The adjacent side in quadrant 4, again, we're right here. The adjacent side in quadrant 4 is a positive 1/2 over the opposite side, negative square root of 3 over 2 equals 1/2 over, times negative 2 over the square root of 3. 2's cancel. We're left with negative 1 over the square root of 3. Rationalize the denominator. We get negative square root of 3 over 3.